So we're talking about the coordinate plane and the equations of a circle. And first thing we want to understand is for the coordinate plane, we have 4 quadrants. So this is quadrant 1, this is quadrant 2, this will be quadrant 3, and this will be quadrant 4. So it goes counterclockwise. And you need to make sure that you're always in the correct quadrant. The next thing we're going to talk about is the distance formula. And so that's our formula. D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So what we want to know, and I'm going to write the formula here so we know what we're working here. So x sub 2 minus x sub 1 squared, and then y sub 2 minus y sub 1 squared. Does it really matter the order in which we put this? No, because we're adding them. So the signs wouldn't matter or anything. So if you put the y's first and then the x's, it really won't make a difference because of the addition with each part, and each part is being squared. So which distance between the points is shorter? Well, we've got a couple of pairs of points. The first point is going to be 1, negative 2, and then 5, comma 3. And then the second points are going to be 5, 3, and 8, 9. So we've got to figure out which one has the shorter distance. So we're going to do the distance formula on both. It usually is very helpful if you label your points, so x1, y1, x sub 2, y sub 2. And we'll do the same thing over here while we're at it. X sub 2, y sub 2. If you label them, you are less likely to grab the wrong value. So d would be equal to the square root x sub 2, 5, minus x sub 1 squared, 3 minus negative 2 squared. So always make sure you bring your signs. And again, it doesn't matter which point you pick as y1 or x sub 1, y sub 1, and x sub 2, y sub 2, because it's going to get squared, so it won't matter. Make sure you bring your radical all the way down. So 5 minus 1 would get us 4 squared. 3 minus a negative 2 actually becomes plus. So this will be 5 squared. So this will get us 4 squared is 16, and 5 squared will be 25. No matter what your points are, or what your values are right here, with the once they're squared, these will always be positive. When we add this, we get the square root of 41. All right, this side over here, we're going to do the same thing. So we have 8 minus 5 squared plus 9 minus 3 squared. So that'll get us the square root of 8 minus 5 would be 3 squared, and 9 minus 3 would be 6 squared. 3 squared would be 9, and 6 squared is 36. And when we add those, we get the square root of 45. So the shorter one is going to be the smaller number. You could take those also to a decimal to see exactly what the value is, but we're just looking at the distance and making it, and that's good enough for what we're looking at. All right, our next example is the midpoint formula, and that's where we take and find the point between 2 points. That formula is x sub 1 plus x sub 2 over 2, comma y sub 1 plus y sub 2 over 2. So you're going to add your x's and divide by 2, and then add your y's and divide by 2. So here are as the points. We're going to find the midpoint. So we have 1, 2, and 5, 6. So again, it's helpful if you label x sub 1, y sub 1, x sub 2, y sub 2. So we're going to add our two x values. So we have 1 plus 5 divided by 2 and 2 plus 6 divided by 2. Well, 1 plus 5 will get us 6 divided by 2, and 2 plus 6 will get us 8 divided by 2. Notice I'm bringing the parentheses down the whole way. This is an ordered pair, so you need to have those parentheses. 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So that would be your final answer. And you do want to reduce if you can. All right, let's do another set. We have 5, 9, and we have 2, 7. Again, I'm going to label. So x sub 1, y sub 2, x sub 2, y sub 2. So we have 5 plus 2 over 2, 9 plus 7 over 2. Well, so 5 plus 2 is 7 divided by 2. 9 plus 7 is 16 divided by 2. So we have 7 over 2 and 8. And we will leave that as a fraction for an exact value versus a decimal point. All right, the next thing we're going to look at is the equation of a circle. So the equation of a circle is going to be x minus h squared plus y minus k squared is equal to r squared. And with that, please understand that h comma k is your center of your circle, and your radius is equal to r. Now, if we have a center of 0, 0, your equation would look like x squared plus y squared is equal to r squared. Because if the center is 0, 0, then all you're left with is your x squared, your y squared, and your r squared. So that gives us a little clarity. So we're going to graph a circle. And we're looking at x squared plus y squared is equal to 25. So we're going to rewrite that as x squared plus y squared is equal to 5 squared so that we can flow more with our equation, because we need that r squared. So we take the square root of 25, and it's just a positive value in this case. So we're looking at our center is going to be at the origin, because it is equal to 0, 0, and our radius is equal to 5. So let's draw a grid. And we need 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's extend that out just a little bit. And then we can put, because our radius is 5 and we're centered at the origin, we will put a dot, and we can mark these as x and y. We'll put a dot at all of the values of 5, and then we're going to draw a circle. So sometimes I'm good at drawing the circles, and sometimes they look more like footballs, so we'll see how today turns out. Not too bad. Not too bad at all. All right, let's go graph another circle. So if we are given x minus 2 squared plus y plus 1 squared is equal to 25, we're going to make this match our formula. So x minus 2 squared plus y minus a negative 1 squared is equal to 5 squared. Now you don't have to rewrite this part, but I want you to understand the formula has a negative sign in it. So let's go back up to our formula. It has a negative in there, y minus k. So if we rewrite it, we can truly see what k is. Otherwise, it's going to be opposite of what you see. So you see a negative 2, your h is 2. You see a positive 1, your k is negative 1. So let's look again at what our center is. Our center is, again, hk, so it'll be 2, negative 1. And our radius is equal to 5. Radiuses are not always, or radii, are not always equal to 5. They just happen to be in the examples. All right, so let's go draw a grid again. Now this time, our center is at 2, negative 1. So we're going to have to go 5 in either direction. So I have to get to 7 on my x values. And then the others won't be as, but I have to make sure I can hit 7 over here. So 1, 2, 3, 4, 5, 6, 7. We've got x, we've got y. 1, 2, 3, 4, 5. 2, 3, 4, 5. 4, 5. All right, so if our center is at positive 2, negative 1, I'm actually going to need a sixth one down here because we're going to go down 1. Now what I'm going to do is count over 5 from there. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And up 1, 2, 3, 4, 5. I can tell that I'm a little off on my spacing, but it'll be fine. Right? 1, 2, yep. Okay, so we're going to come up and curve. We're not dealing with a perfect drawn graph. Totally missed my point. So we'll just make our point a little bit bigger. All right, so he looks a little more square, but it's all good. All right, so that's how we draw the graphs. Now let's find the equation of a circle. With a radius equal to 3, and the center is negative 2, positive 2, positive 2, negative 5. All right, so we're going back to our formula. Remember, our formula is x minus h squared plus y minus k squared is equal to r squared. So this will be x minus 2 squared plus y minus a negative 5, because this is our h and our k squared is equal to our r squared. So let's clean this up a little bit. We have x minus 2 squared plus y plus 5 squared is equal to 9. All right, let's find another way to find our equation of a circle. So find the equation of a circle. And we are given point P as 1, 8, and point Q of 5, negative 6. And these are the endpoints of the diameter. So remember that the diameter goes through the middle of a circle. So if this is our circle, our diameter goes across. And it can run across any point. I mean, it's just the diameter. So it's twice the radius. So we need to find the center because of our circle, and we can find that by finding the midpoint between these. Because if we look at our diameter going across, the midpoint of the diameter is the center of our circle. So the center is the midpoint. So what we need to do is find our midpoint. So this again, x1, y1, x2, y2. All right, so we've got 1 plus 5 divided by 2, and 8 plus a negative 6 divided by 2. So that'll get us 6 divided by 2, and 8 plus a negative 6, same thing as 8 minus 6, which will be 2 divided by 2. So that'll get us 3, 1. So we found the center of our circle, which will be our h and k. Now we need to find our r squared. Let's get need a little bit more space here. So we found the midpoint, which is our center, but we've got to find the radius. So to find the radius, we're going to do the distance. So remember again that the diameter is going across, and it's the distance between those, and half of that distance is going to be the radius. Well, we have a distance formula, so we're going to find our distance of our, or the radius through the distance formula. So let's find r squared through the distance formula. So r squared is equal to, so if you remember, our distance formula is d is equal to the square root. Well, if we square the distance, it's equal to, and we square both sides, and we just have this part with the x squared minus x, or x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if we square both sides, we get a square over here, and we don't have the square root. So we're just going to plug in without using the square root because we're going to find our r squared. Because we need r squared for the formula. So we have x minus x sub 1 squared plus y minus y sub 1 squared, or you can do your x squared or x sub 2 minus x sub 1 as long as they're two different values. And our points again are our 1, 8 and our 5, negative 6. So we have r squared is equal to we're using the center of our circle. I'm like, okay, so what are we doing? We're using the center, and we're going to use one of the points. Sorry about that. All right, so instead of using both points up there, to find our r, it would be from the center to the other. So if we're looking for just r, because we did find the center already, we can find the distance just from here to here, because that would be the radius right there. So instead of finding the whole distance between the two and then having to divide, we'll just find the distance right there, because that is our radius. All right, so we're going to use the point of our center that we found of 3, 1, and then we're going to use the point, let's just pick the 1, 8. It doesn't matter which one. All righty, so our r squared is going to be equal to, here's our x sub 1, our y sub 1, x sub 2, y sub 2. Oh, actually we're doing x sub 1, and then we've got the other. It doesn't matter. So we can also put this as 2. Let's put this as 2 and 2 right there. It'll just make it easier for us. Alrighty. So we're going to have x sub 2 would be 1 minus 3 squared plus, we'll have 8 minus 1 squared. Well, then that tells us that our r squared is equal to negative 2 squared plus 7 squared. Now, negative 2 squared is still going to be a positive, so r squared is equal to 4 plus 49, so our r squared is equal to 53. Now, we need to know what r squared is for our equation of a circle. So to remind ourselves of that equation, x minus h squared plus y minus k squared is equal to r squared. So x minus our circle center was 3, 1, so 3 squared plus y minus 1 squared is equal to 53. And that would be finding the equation of a circle through the two endpoints of the diameter.